Okay, in Chapter 10, we're going to be talking about perimeter, area, circumference. And in Lesson 10.1, we're specifically going to be talking about the area for triangles and quadrilaterals. If we take a look, the area addition postulate says that the area of a region is equal to the sum of the areas of its non-overlapping parts. Now, we know that to find the area of a rectangle, we know we take the base times height, or length times width. Well, down below, they're trying to show us how we can find the area of a parallelogram. It says you can use the area addition postulate to see that a parallelogram has the same area as a rectangle with the same base and height. What is being shown here is if I had my parallelogram and I took and I cut off or sliced that triangle and rotated it over, that we would actually end up with a rectangle. And so, to find the area of a parallelogram, we are going to say that our formula is to simply take base times the height. Now, there are a couple things we want to be sure of. Our height or our altitude must meet the base at 90 degrees. Here, this is shown going right down the middle, but it actually doesn't matter. Our height segment could be right here. It could be right here, or so on, as long as it meets the base at 90 degrees. We just know that we would not use one of the slanty lines as our height or our altitude. Also, we want to keep in mind that our rectangles and squares are also parallelograms. Sometimes the area of a square you can see as written as A equals S squared, but that really is the base and the height. It's simply that all sides are the same, S times S. Looking down below at example A, we have a parallelogram. Side lengths measuring 11 millimeters and 34 millimeters. Now, with this given parallelogram, I do not have enough information to find my area. If I used 11 as my base, 34 would not be my height. And even if I thought of 34 as my base, 11 is not the height. Sometimes they will show the segment or the height of a parallelogram given outside the figure. Now, just if we had been given my length here of 33 millimeters, drawn in these segments, I would then be able to calculate h for my height. Okay? The dotted line does not mean it is a segment for the parallelogram. It is simply showing the measurement, height, top to bottom. Now, if I needed to calculate, I actually do have a right triangle in there. I could use the Pythagorean theorem. This actually will come out as a Pythagorean triple, and we would find that our height would be 16 millimeters. Now, I could go ahead and calculate the area of my parallelogram. Base times height. We know that if we use a base of 11, the height would be 16. It is meeting a segment containing the base here at 90 degrees. And we know that when we label, we need to label that as units squared. So this would be 176 millimeters squared. What's the difference between a millimeter and a square millimeter? Well, I'm going to enlarge it. Maybe I'll talk about a centimeter and a square centimeter. This would be 1 linear centimeter, where this would be 1 square centimeter, because it's 1 centimeter by 1 centimeter. And so you can see those are two very different units of measure. That is why our label is important. take a look at a couple more. They're going to throw in some algebra today. In example number 2, they say, ask us to find the height of a rectangle in which the base equals 3 inches and the area equals 6x squared plus 24x minus 6 square inches. Well, again, if I'm thinking about my formula for rectangle, area equals base times height, I'm going to plug in the information that I know. I know my area is 6x squared plus 24x minus 6. I know that my base is 3, and I am essentially looking for my height. So here I would be solving for h. I know that if I wanted to solve for h, I need to divide both sides by 3. Now I'll just remind you that when you divide by 3 on the left-hand side, we're going to be dividing each term by 3. And so we would find then that our height would be equal to 2x squared plus 8x minus 2. This would be a linear unit, so this would be in inches. And that's all I'm going to do with my final answer. We're going to give it as an expression. Question number 3, it asks us to find the perimeter of a rectangle if it has the area of 12x square feet and one side measures 6 feet. Now sometimes I do like to give myself a picture. It is not required, but in this case it's telling me my area is 12x square feet and one side measures 6 feet. I'm looking for my perimeter. Well, we know that if we need the perimeter, we need to think about what our other side measure is going to be. If my area is 12x squared, well, area is base times height. One of my sides, I'm going to just think about that as being the base measure is 6. To find the other length, we would simply divide. We would find out then that our other side measure, which I'm referring to as my height, would have to be 2x. Excuse me, this is 12x, 12x squared. Okay, if my other side measures 2x, now the question is, what is my perimeter? Well, we know for the perimeter we need to add up all 4 sides, 6 plus 2x plus 6 plus 2x, and we're simply going to combine our like terms. Here we would give our perimeter as 12 plus 4x, and that would be in feet. It's a linear measure, so it is feet and not feet squared. Okay, if we needed to find the area of a triangle, we know that the area of a triangle is 1/2 base times height, or you may have learned it as base times height divided by 2. Those mean the same thing. A trapezoid, we know a trapezoid has a set of parallel sides, which we call the bases. In this case, we're going to call it base 1 and base 2. My area is equal to 1/2 times the quantity base 1 plus base 2 times the height. Why is that? Well, similar to a rectangle where we would do base times height, but because my bases are different lengths, you'll notice here we actually take and we average those bases before we times it by the height. Okay. In example B, they ask me to find the base of my triangle in which the area is 15x squared centimeters squared. Well, again, I like to start with my formula and plug in the information that I know. In this case, I know my area is 15x squared. I can see from the picture here that my altitude or my height is 5x, where I'm looking for the base. So I'm going to go ahead and make that substitution. Now there's different ways you could go about solving this for B. I'm going to go ahead and multiply by 2 so that I can get rid of my fraction. And then I know if I'm solving for b, I'm going to divide by 5x. Again, we're kind of reviewing our algebra here, but if I take 30x squared divided by 5x, I'm going to end up with 6x, in this case 6x centimeters. This is going to be a linear measure, and we want to make sure that we are labeling our answers. Question 2. It's asked me to find base 2 of the trapezoid in which my area is 231 square millimeters. Here you'll notice they give me my height or my altitude of my trapezoid outside the figure, but it's a dotted line. That's not actually a segment of the figure. It's just showing. That could have also been given right down the middle. If this is 11, this is 11. Now, my trapezoid, again, I like to start with my formula and then go ahead and plug in what we know. We know the area is 231. As we look at the picture, I can see here that my base 1 is 23. I'm looking for base 2, and we have a height of 11. Now, again, there are different ways that you could go about solving this question. I typically would start by, again, getting rid of that fraction by multiplying by 2, but that is not a must for your first step. What would I do next? Well, this is in parentheses, remember? And so when we're solving our equation, we're actually working our order of operations backwards. So we actually want to take a look at dividing by 11. And we would find that 42 is equal to 23 plus base 2, and we would subtract. In the end, we find out that our base 2 is 19 millimeters. Okay. Moving along, we can also take a look at a couple other quadrilaterals. These may not be quite as familiar to you. The formula for a kite and a rhombus. So in my first picture, I have given kite, and if we are looking to find the area, it is given by this formula, 1/2 times d1 times d2. What does d1 and d2 stand for? They stand for diagonal. Okay. Actually, over here, my rhombus, the formula is exactly the same. 1/2 times d1 times d2. Now, I will tell you also that a rhombus is a parallelogram, so we could also think about that as base times height, depending on what information you are given. So as we take a look at example C, they ask us to find the diagonal 2 of a kite in which diagonal 1 is 14 and the area is 238. We're thinking about our formula, and again, in this case, we're just working backwards to solve. My area is 238. My diagonal 1 is 14, and I'm looking for diagonal 2. Now, previous examples, I have shown you solving to get rid of your fraction first, and I certainly could multiply both sides by 2. But because this formula is set up strictly with multiplication, I could also think about doing a little bit of simplifying. So if I take and multiply, I could think about that as 7 times d2 and then divide. Either way you go about that, we will end up with the same answer. We divide by 7 and we find out that our diagonal 2 is 34 inches. Question number 2 is asking me to find the area of my kite. This question is a little bit more intense. I don't have all the information that I really need. I need the length of my diagonals, and I can see I'm missing some of that information. Well, if this is a kite, we do know that we have some congruent sides. But the other key piece of information to remember with our kite is that my diagonals meet at 90 degrees. So we do actually have some right triangles that are formed. And if I take a look here at this right triangle, I can go ahead and solve for y first, as I can use the Pythagorean theorem. 35 squared plus y squared. Oh, excuse me, 35 is my hypotenuse, so we're going to say 35 squared equals y squared plus 28 squared. If we go ahead and solve, we'd actually end up finding that y is 21. And so once I solve for that, I do like to label. And if y is 21, we are now actually able to solve for x. Here, I can use my smaller triangle. 29 is my hypotenuse. And we can say 21 squared plus x squared. And if we go through and we solve, we would find out x is equal to 20. Now, my triangles here actually end up having some congruent triangles. And so if this is 21, this is going to be 21. What does that mean about finding the area? Well, my area of my kite is 1/2 times d1 times d2. Or diagonal 1, well, one of them, 21 plus 21, I can see is going to be 42. And 20 and 28 is going to be a length of 48. In the end, we're going to find out that our area is 1,008 square inches. Finally, in question 3, they ask us to find the area of a rhombus where D1 is 6x plus 4 and D2 is 10x plus 10. My area, 1/2 times diagonal 1 times diagonal 2. When I go ahead and substitute that in, again, we are simply multiplying 3 terms together. I could go about this a couple different ways. If I wanted to start by multiplying the first 2 terms, 1/2 times 6x plus 4, I could go ahead and distribute that if I want. This would give me 3x plus 2. I still need to multiply that by the 10x plus 10. So what is this going to require me to do? Yes, I'm either going to have to FOIL it out or to box. And let's see, let's FOIL this out. So we would have 30x squared plus 30x, 20x, and 20. I'm going to go ahead and simplify. So my answer is going to be given as an expression. This is 30x squared plus 50x plus 20. If there's no label given, we're just going to label this as units squared. Okay, let's take a look at one more. In example D, we have a triangle, and they're asking us to find the area in terms of x, meaning typically we would have some x's in our answer. Well, looking at our triangle, I can see if this is 30 and 90, that this is going to have to be 60 degrees. So we actually have our special right triangle. We know that if our short leg is x, our hypotenuse is double, and our long leg is the short leg times root 3. What would we do to find our area? Well, area of our triangle is 1/2 base times height. Here, we know our base and our height have to meet at 90 degrees, so we can use our short leg and our long leg as our base and our height. A lot of times kids will think about x root 3 as the base and the height as x. Now, the only thing that I'm going to ask is that you give your answer in simplified form. So I'm going to want to think about multiplying this out and how I can simplify. If I take and I multiply, if I think about these as fractions, I would do the top over the bottom. Well, 1 times x root 3 times x is actually going to give me x squared root 3 all over 2. This would be my area in simplified form. Okay, if you have further questions on